Welcome back, everybody. What a joy to see you back joining us again. And I hope you're having as much fun on day two as we all are behind the scenes here as well. And that you've spent some time in the break visiting the exhibitors, as well as tagging yourself and your colleagues in social media. This really is the place to be right now for anyone inside the industry. Right, we're moving ahead very nicely and running perfectly on time for those of you very keen clock watchers. So here we go. Our next presenter coming up is Mario Zagar, who's the principal engineering architect at Infobip. He's going to be talking about how Infobip uses Azure to deliver 500 million WhatsApp messages. And nobody's more qualified than Mario to take us through this. As a solutions architect and development lead, he's got over 10 years of experience designing, developing, deploying, and maintaining mission-critical applications across the automotive and telecommunications industries. He's been with Infobip a bit longer than that, 11 years, I think, in total so far. And his specialities are software design patterns, real-time systems, and agile software development. He's passionate about his subject, as you're about to discover. Let's welcome Mario to the platform. Hello, sir. Nice to have you with us.
So thank you, Michael, for the introduction. Welcome everyone to this presentation. I'm very happy and excited to discuss with you today our WhatsApp use case and how we use Azure to run it. Agenda for today is organized only in several points. First point is just describing the use case in short, then discussing the architecture, how it is built, and how we deploy it into production and how we operate it. And finally, I want to share some hard learned lessons that we kind of accumulated over the years. So Infobip is a communications service company. We provide services to businesses to easily engage with their customers. And the company has grown over the years, and today we are located in data centers. We have over 15 locations around the world to provide the fast service to our customers. We have almost 3,000 people inside the company, and the amount of the operational knowledge we need to have to run the platform in all of these data centers has become a significant challenge for us. So what does it mean, communications platform as a service? Basically, what it means is that on one side we have a business that wishes to engage with their customers, usually over the phone, and in the middle there is Infobip, a company that provides this communication and enables this communication to flow like seamlessly and easy. So initially, the communication channel we used to connect the businesses and their customers was SMS, right? But over the time, we introduced other communication channels. So now businesses can use, for example, voice, RCS, push notifications, Viber, Telegram messages, WhatsApp messages to reach their customers. Of course, on top of these communication channels, we provide some other value-added services to those businesses so that they can make this communication with their customers more fluent and provide some other services and value on top of just plainly sending the messages to the customers. So one of those communications channels is WhatsApp. And WhatsApp has been a very popular communication channel, and more businesses use it because it has a large base of basically people using WhatsApp. So today, in terms of Infobip, we are servicing around 1,800 customers with providing them our WhatsApp product. These customers, basically what they do, they buy several numbers, one or more WhatsApp numbers, which they use as a point of communication, like a business WhatsApp number for their customers to reach them. So basically on my phone, if I want to talk to some business, I will just open the WhatsApp application and directly message the business I'm interested in. And this is how this communication is working. So with this amount of customers and basically WhatsApp business numbers, we have a large number of messages going in and out of our platform, reaching those end subscribers and reaching the businesses. Currently, per month, we see around 20 million active users using the WhatsApp service. So these are the people that actually kind of receive the messages on their phone and interact with the businesses. And this kind of accumulates to around 500 million monthly interactions, messages being exchanged over the Infobip platform, which is a pretty fascinating number. So the use cases we see are mostly around customer engagement and improving customer service. And the industry which uses this WhatsApp product is basically like different. We see finance industries, banks, insurances. We see travel, lots of companies from travel industry. We see retail. So basically, wherever we need this customer engagement and customer service, we can use one of the channels, and the WhatsApp is a popular channel to do it. So how does this actually work? And everything starts by business sending an API call to Infobip platform, right? So a business wants to reach a customer, they want to send a message to the customer's phone, so they will just call a simple API on the Infobip platform to send this message, and for this message to get delivered to the phone. Infobip platform will receive this message and accept it for processing. After processing this message, Infobip platform will find the appropriate API to use to deliver this message. Now, this API, this can be like operator if we are talking about SMS. It can be, Viber API if we are talking about Viber messages. It can be, some push API if we're talking about push notifications, and so on. And after calling this API, basically the message gets delivered to the end user's phone, and the end user sees it. Of course, the communication also flows in other direction. So when an end user types a message on this phone, it will reach us over the cloud. Somehow it will reach the Infobip platform, and we will push it to the customer or provide some service for this message. But for WhatsApp, the situation is different, right? There is no public API exposed by WhatsApp, which anyone can call. Instead, what happens is Facebook, being the owner of WhatsApp, they provide the appliance that we need to run on premise, right? So any WhatsApp provider needs to take this appliance, run it on their infrastructure, on their data center, and basically this is how we get access to the WhatsApp API for sending and receiving the messages. Then this appliance actually, through some proprietary protocols, connects to WhatsApp servers in the cloud and communicates about receiving and sending the messages. So our entry point is basically this appliance. So what is the architecture of this appliance? What WhatsApp provides is 3 applications in form of Docker images that we need to run. These applications require MySQL database to operate. For sending and interchanging the media messages over WhatsApp, these applications also require a media file share, where these media files like PDFs, videos, images will be stored. So Infobip core platform connects to this API over HTTPS. So we communicate with this web application when we are sending a message. Then this web application sends this message to the core application, and the core application connects to the Facebook WhatsApp servers and will actually, send the message to the server and finally to end user. And when we are receiving messages from the end user, it goes similarly in the other direction. The core application will receive the message from the Facebook servers, and then we'll push it to our platform. So this is theory, how it looks like, and the architecture, the high-level overview of the components involved. But now let's look at how actually we deploy this. And over the years, and we have now been operating WhatsApp and providing WhatsApp services for almost 3 years now. So the first iteration that we did is deploying these applications directly on top of virtual machines and running them as Docker containers. So what we would do, we would provision a virtual machine, install the applications on top of it, provision one more virtual machine with the same set of applications just to be redundant in case of failure, provide the MySQL and the file share required for these applications to operate. So this was a great way to start, especially when there were not so many customers involved, and when this WhatsApp product wasn't really yet kind of mature and didn't have lots of traffic. But we soon noticed that we have some challenges here, mostly related to handling all of these virtual machines and maintaining them. Then it was difficult to add new instances of applications because we need to now provision virtual machine just to install these applications to handle more traffic. And also it was not efficient how we handle the resources because we had lots of virtual machines doing basically nothing. And just to show you, for around 300 customers, we were running more than 1,000 virtual machines. Right, but when we looked at what these virtual machines and how much resources they actually use, right, the numbers were we got was basically 50% of resources are not used, and the resource usage was pretty ineffective. So, of course, like the first question we ask ourselves, can we get rid of these VMs and not think about VMs? And the answer to this was let's try to use Kubernetes. So this is an orchestration platform that actually provides exactly that. Stop thinking about virtual machines, just think about applications, and Kubernetes will take care where and how these applications are started. So this was a good idea to try for us. So what we did, we installed the Kubernetes cluster, and now we kind of organized it so that we isolate the appliances in Kubernetes namespace, right? They provide some isolation so that everything regarding deployment for one appliance, just we put in this one single namespace. So then we deploy the applications inside this namespace, and of course provided the MySQL. And the MySQL we are also running inside the Kubernetes, and we provided the Ceph network block storage as a place where we kind of keep the data. And it is a open source solution with redundancy built in, so it was a safe way where to store the data for MySQL for these appliances. And of course, we provided the media file share on a dedicated storage. It's basically a Windows machine providing a file share for these media files. So when we did this switch to Kubernetes, it immediately started to be easy to operate and deploy these appliances at scale. Right, and also it was easier to maintain because now all the maintenance was done through a single Kubernetes API. We don't need to go to virtual machines to change something, tweak something. We just use the Kubernetes API. Of course, adding more instances now just becomes basically changing one number. We say, okay, now instead of 5 instances, I just want to have 10, or instead of 1 web application, I want to have 4, and so on. So this was really super. And the resource usage improved significantly because now Kubernetes was taking care, how to pack these applications together to use the resources in most efficient way. But the downside of this setup on-premise was that now we were responsible for these Kubernetes clusters, and we needed to manage all of this infrastructure together with the applications that we run on top of it. And this proved challenging, right? And we also had another major challenge with more customers. When WhatsApp was gaining popularity and we had more and more traffic, basically we needed more and more resources to handle this traffic. And getting a new resource, like a new hardware machine, putting it in a data center, hooking it up, this takes time, especially in these times. So, to get a new machine in the data center, it can take months, right? And we just cannot afford to wait that long. So we started thinking about how can we solve this challenge, right? And the first thing that comes to mind, can we just use some resources from the cloud, right? Can we have some hybrid setup where we run on-premise, but also in the cloud? And since we were already using some of Microsoft cloud services, we thought of let's try to just switch our Kubernetes cluster, which we run on-prem, with managed one from Azure, and let's see how that works, right? So what we did, we took our initial setup of Kubernetes clusters, right, and basically just installed the applications in AKS. And the only thing we needed to change basically was where do we store the data? Of course, in cloud on Azure, we need to store data on Azure provided services. So basically for MySQL and for file share, we just changed one flag which says, please use the Azure managed disk for MySQL, and please use Azure File Premium Storage for media file shares, right? This was all one change. And this is, exactly that. Just change the line which says, use different storage class, right, to provide the storage. So at this point, it was kind of evident that we can use the same things that we run on premise also in the cloud, and we keep all the benefits, right? And we get one added bonus, which is basically we don't need to manage these Kubernetes clusters ourselves. We don't need to think about how to provision it. We just click, right? And new cluster is provisioned. We don't need to think about how to add more worker nodes. We just click and new worker nodes appear. So this is super. Also, we don't need to think how to upgrade. The upgrade is built in, right? So how does this appliance looks under the hood running on this Azure cluster, right? And it looks exactly like it did on our on-premise, right? So these are the pods that are running on Kubernetes cluster inside the namespace assigned to this appliance. And we can see that we have two core applications running. We can see that we have two master applications running. We can see two web applications running, and also we can see MySQL, which is running in a highly available cluster mode setup, right? So in case one of the worker nodes goes down, the traffic is not affected, right? The applications will just continue to work with the other application instance of MySQL, which is running, right? And in terms of storage, we can see that here are we using managed premium Azure disks to provide backend storage for MySQL instances, and also we are using Azure File storage class for providing backend storage for media file share. So this was all like a proof of concept. We saw that we can do it. It looks similar. We use the same Kubernetes API to manage everything. So this is all fine, and it looked like it can work. But now we needed to connect the appliances now running on Azure to our core platform running on premise. So how did we do it? When customer calls some API on Infobip platform, in reality, there is not just single data center. There are two data centers running, and these two data centers, they are physical buildings, kind of separated by several kilometers, right? And this is all transparent to the customer, right? And now we need to somehow connect these resources that are provided in Azure, and what we do is we see, what is the nearest region that Azure offers nearest to our data centers, and we connect them with, express route. The express route is just a network cable, basically, connecting these locations in a redundant way, and it provides low latency links. So, which is super important for us, because this should be. I should not be aware that this is a resource running in Azure, right? It should be totally the same thing as running on-prem. Okay, so now that we have this link to Azure, we can start provisioning Kubernetes clusters. And we provision managed Kubernetes clusters there, and we deploy appliances in those Kubernetes clusters. Of course, like before, these appliances connect to WhatsApp servers in the cloud to exchange the messages. To be able to communicate with specific appliance, because every customer gets its own appliance and its own dedicated WhatsApp number, we need to somehow target specific appliances. So in order to do that, we put a load balancer in front of it, right? So now we can choose exactly via URL, simple URL mechanism, which target we want to, which appliance we want to target. And when we have that, it is now easy to connect our core platform with the appliances. We have the network connectivity, we have the load balancer. Basically, the core platform is totally unaware that this is running in Azure and not on-prem in our own data center. So after doing it with one cluster, we just continue to add multiple clusters when we needed them inside this region, and it works exactly the same. And the great thing about Azure is that you pay basically just for the worker nodes. You don't pay for the Kubernetes control plane, for the master nodes, and for the API servers, and all of these components in the controller plane of the Kubernetes cluster. You just pay for what you use. So this was also a nice feature to have. So now at this moment we are using two regions. One is in West Europe, one is in Central India, where we deploy these Kubernetes clusters in this way and put WhatsApp appliances on top of them. And this amounts to around 15 clusters currently running these appliances. And this is when we look at how many worker nodes we have around 560 worker nodes across all of these clusters, which when compared to this 1000 that we had when we started, is handling a lot more customers, right, with a lot less worker nodes, and plus we don't need to think about them. And in terms of how many appliances on this cluster, on these 15 clusters, we have around 3000 appliances, right? And we try to put around 200 appliances per cluster. All of this is managed and operated by a 10-person team, who creates those clusters, who manages those clusters, and basically it is their focus is mostly on automation, because at the scale that we operate and it's getting bigger and bigger, we just don't have time to do anything manually. So whatever we do, we're trying to see how to automate it. So one important aspect of this is how we monitor all of these 3000 appliances that we are operating, right? And what we want to do is basically we want to get a good sense of what actually the customer's business and the end user is feeling when this traffic flows over the Infobip platform. This means exactly, how much latency, how much delay does Infobip platform introduce into this communication, right? And it should be as fast as possible. So for this, we use different set of tools like Prometheus, Grafana, Elasticsearch to get out these numbers. And this allows us to monitor every specific appliance and to know exactly how much delay this customer feels in delivering messages to end users, and also what percentage of this traffic is affected with, let's say, poor performance, right? And also we can monitor the other side, from when the message reaches us from the end user's phone, how much time does it take for us to kind of process it and push it to the customer so that the customer can do their business. The other monitoring that we do is the infrastructure monitoring. So although this Azure Kubernetes cluster is managed, we still need to somehow monitor the performance of all of these clusters, right? And the performance of applications running on top of it. And because when we're running on-prem Kubernetes, we use New Relic, we just continue to use it. It was the easiest things to do. But for monitoring Kubernetes managed disks and performance of file shares, we just use Azure Metrics. They are a good enough tool for us to do so, and it allows us to understand, how well the file share performs, how well the disks perform used by MySQL, and so on. And here you can see how it looks like. We can see the spikes, we can filter and basically find out if we have any problems and when. And we can also, of course, alert on these metrics so that we know when we need to react. So this is the good part. On slides, everything looks great, and it is very it looks like we didn't have much problems in reaching this stage. But along the way, we learned a lot of lessons the hard way, right? And some we expected, but lots of those lessons that we learned were just, I think, impossible to learn without reaching the scales that we are operating on now. So in this last section, I would like to share with you the lessons we learned that I would really like to have known before we started the migration to Azure, to get more prepared. So one of the things that we learned is that it is better to have multiple smaller clusters than one bigger, right, or two big ones. And it is mostly related to how much API calls the worker nodes are exchanged with the Kubernetes control plane, with the API server, right? And we had some challenges there and some problems. So in the end, we just decided to use multiple smaller clusters so that this load and the chatter on the Kubernetes level is smaller and manageable, right? Also, it is good when we are upgrading or some cluster has problems, not all workloads running there are affected. Also, we have learned, and this is a recent feature in Azure, Kubernetes service use the ephemeral disk. What does this mean? Originally, when we started with Kubernetes, all of the applications, all of the worker nodes on Kubernetes used network disks to store the operating system, right? So this allows you, when the worker node goes down, you can just start up and you will not lose any data. But in reality, we don't need it. And this caused this network OS, this caused us some problems because we started hitting some IOPS thresholds and performance issues, and it was due to this high network traffic that happens when operating system performs some operations on those disks, and we just switched to ephemeral ones. This means this is just a disk exactly on the hardware machine where this worker node is running, and if this virtual machine dies, we lose all the data. But it is not important to us. We can afford to lose the data because the data is stored on file shares and MySQL storage disks, which are redundant. So we switched to these ephemeral OS disks. Also, it was important to understand the storage limits. When we will hit some limit in performance in file share, when we will hit, and what is the limit that we see in Azure disks, and how do we provision Azure disks for MySQL with enough IOPS limits that we need actually to run specific appliance. And one thing that in the end crystallized for us, although the upgrades of Kubernetes cluster in Azure are automatic, right, and they perform fine, we do not have a control when this process starts. We lose control which customer is going to be services for appliance for these customers will be stopped and started again. So this was totally out of our control. So instead of upgrading the clusters, what we do now, we just create a new cluster in the new version and migrate the appliances to this new cluster. So instead of upgrading, we just create new clusters, migrate, and then delete the old clusters. And this proved a lot better because now we are under control. We choose when to do it. We choose which customers to migrate and when to have minimum impact, ideally no impact at all to customers' traffic. So we have been operating this WhatsApp product for almost 3 years now, and 2 of those years were on Kubernetes. And the fact that we started running this Kubernetes on premise, and we needed to manage this infrastructure ourselves, proved to be great help when we migrate to AKS, because we knew what we should expect. We knew how the system should behave. So lots of situations that we had where something strange was happening on the Azure Kubernetes clusters, we know where to look for the solutions, right? And with the help of Microsoft support, we could get the system to run as efficient as on-prem. And so far, we have been very satisfied with how Azure provides the quality of the services that Azure provides for our workloads and for running these appliances. And we are continuing to deploy more and more customers directly on Azure, and this is our platform of choice. Basically, whenever we need to provision new appliances, and we are kind of cutting down on our on-premise clusters. So this is it. Thank you very much. It was a pleasure to share this presentation with you. I hope you got a lot of useful information. And Michael, now back to you.
Mario, I should have introduced you as a rocket scientist as well. My goodness. Kubernetes, you had me going there for a moment. I had to look it up. It's an ancient Greek word for somebody who helps steer a ship, which is why I guess Kubernetes is the open source container orchestration system for automatic deployment, scaling, and management. Oh, I've impressed myself there. It's kind of remarkable, really, isn't it? What I'd like to do now, ladies and gentlemen, as Mario moves over to the speaker lounge, you can take live questions with him there or in his private speaker booth as well, should you want to go private with it. He'll happily take those questions while we move on